Hello, everybody. Welcome back. This is Brian and Brian for Breaking Security.
Hello, guys.
Man, I'm telling you, it's crazy time here at Casa de Breaking Security. Our green room is always full of people, and we managed to get another gentleman, Paul Coggin.
Thank you.
Yep.
Glad to be here.
Yes, sir. It's great to have you here. So, why don't you tell us a little bit about yourself? You know, most security superheroes have an origin story. Why don't you fill us in on how you got to be where you are today in information security?
So I got into IT in '94. Started out as a network system admin doing VMS, Unix, Windows. Pivoted into routing, switching, wide area networks, firewalls, consulting around the '99 timeframe, and as well as penetration testing and doing security assessments for HIPAA. And over time, navigated more toward being a hardcore network infrastructure person with, and from a security standpoint, specializing and focusing on how to defend and break into network infrastructure. And these days, for the last few years, I've been doing the network infrastructure security consulting and also doing a great deal of training and speaking whenever I have the opportunity around the world. So pretty broad background, but like I said, I focus on network infrastructure security.
Okay, so you kind of go on like the world tour, as an instructor for EC Council and also speaking engagements.
So I teach for various partners. I teach for Firebrand in the UK, CED Solutions out of Atlanta. I work for Dianetics out of Huntsville, but I'll go and teach. I teach for CED Solutions and Firebrand whenever they need an instructor, and I do consulting. But I work for Dianetics out of Huntsville, Alabama, an aerospace company, and so I generally just do consulting. Whoever needs my help, I go work for as needed.
Yeah,
and so it sends me around the world.
Wow,
it's been very lucky.
So on last week's episode, we talked about we had an SNMP primer. Can you tell us how someone can use this protocol to hack a router?
Yeah, what you will see out in the wild is in many cases, routers will have a default SNMP community string set up and will have an open trust relationship so that anyone can touch it with SNMP UDP packets. And if you can guess the private community string, then you can go in and manage it just like you would if you had root on a Linux box or admin on a Windows box. Or they may be able to guess the SNMP community strings by coming up with a custom dictionary, just like you would come up with a custom set of passwords. You come up with a custom SNMP community strings, and surprisingly, it works. And it could enable you to take over a switch.
Can you give me an example of where one worked? I mean, I can't imagine. Is it like the company name or something?
It could be a company name, names associated with the organization, projects, and there's many examples where the networks are being hacked like that. I mean, there was a few years ago a young man about 17, 18 years old that just used defaults and built his own long-distance voice company with easy guess SNMP community strings, capturing people's routers across the internet. It's really common. Now, granted, with the Cisco routers, you have to go out of your way and put in those easy to guess SNMP community strings yourself manually. But there's a lot of network equipment that has it built in by default, and people just don't bother to change it. And so it opens it up to remote management.
Okay. Are there any other ways to hack a router? I mean, other than guessing the community string?
What I typically find is during a penetration test engagement, we will find the configuration files for a router or switch out on a file server. Someone will find a directory traversal opportunity where you can just go and read files, or maybe get a shell, say with maybe just read-only access. But we're able to traverse through the directories and read files and find, say, the TFTP directory and able to find the key configuration files that give you the information you need so that you can identify the trust relationships so that you can zero in your attack to know what systems to go after so that the trust relationships can be exploited and in turn take over the network infrastructure. Say, like, specifically what you would go after is trying to find the systems that are managing, say, SolarWinds, Cisco Works, HP OpenView. Those
Okay.
type of systems would be the key so that you can circumvent the infrastructure security that's in place, because there's going to be a trust relationship to that network management system. And if you can find that, if you can discover that during your engagement, it's going to make taking over the network real easy.
So you said just find the network management system somewhere, but you still have to, hack that box, right?
Right. But what happens with the network management system in many cases, it will have many applications running on it, and probably possibly numerous web server applications, databases, possibly running on a older operating system like an old Solaris box. You might find some old HP-UX, depending on the organization that you're dealing with. And because it has those numerous web servers, not all of them are secure, and they're going to have default settings, misconfigurations, and somewhere in that setup, there's going to be an opportunity. Because what happens is, in many cases, the person who sets up those network management systems may be the router guy who may be very fluent in a router network infrastructure platform, but is not fluent. You can't be fluent in everything. You can't be an application guy, database, OS, Unix, Windows, everything. As good as you may be at routing protocols, that doesn't equate to being an expert at all the web apps, et cetera. So all you have to do is figure out where they messed up and take over that system, and then escalate your privilege.
Yeah, that's true. I mean, one of like the SANS top 20, one of them is, or just in general, a good security practice is to separate these duties. You shouldn't mix your web server with a database server, with your application, with your network management system, like what you talked about. Right. Chances are they're not being managed properly to begin with if you do that. So I think you're right. I think it's easy pickings in that case. Let's talk about IP spoofing. I can see how you may be able to change the password with IP spoofing. It's sort of like a blind injection, the way I see it. But How can you download a router config by spoofing an IP? It doesn't seem like you could, because you can send traffic, but you're spoofing an IP, so you don't get anything in return. I don't see how that works.
So with SNMP uses UDP 161 and port 162, and 161 is what the network management system is going to use to communicate to the endpoint device. And so if that endpoint device, say a router, for instance, has a access list applied to it to secure the SNMP protocol, if they do not have anti-spoofing implemented across the network to stop someone from spoofing packets from the access layer or the perimeter in toward the core infrastructure, if they do not have those trust relationships locked down, then you can spike SNMP UDP packets toward that network device. And if you can guess the correct SNMP community string, you could have an SNMP command that you probe the device from one IP address and have an SNMP command that tells it to download the config to a different IP address. So the IP address that you're initiating the connection from does not have to be the IP address that you want to specify to download and archive the config or operating system to. And an example of that is using there's a script called SNMP blow that demonstrates that.
Mm-hmm. Yeah, I saw that in your video. That was
right.
Something I'm definitely going to be looking up when I go to work and start playing around with the network at my office. So.
And it works. I've proven in other in real world scenarios that works. And the key thing is someone may understand how to apply an access control list to the SNMP configuration, but they fail to implement anti-spoofing measures across the network. And, from a bad guy standpoint, or if you're, doing a red team penetration test, all you have to do is find that one place where they messed up and forgot to implement a security control.
What's your record of success on that? Like, what percentage of the time do you find, if there's no anti-spoofing enabled, are you able to pop a router?
Well, that doesn't always work, because some of the networks they're under some pretty rigorous policy audit, and so they will go and come up with complex community strings because of their password policies. So it's hit or miss. It's not 100%, but it does work. I mean, I don't have any statistics, but we've used it and it works on a number of occasions. But the big thing that I wanted to get across with that presentation at DerbyCon was to understand how you could defeat access lists and defeat those trust relationships if anti-spoofing is not implemented. If you haven't thought about every step of the way, all the different trust relationships that need to be secured, though you may not be able to get a TCP connection and pop a shell with, say, Metasploit, if UDP is a good platform, because what I see in many pen tests, a lot of the young pen testers are always looking for a TCP connection, but UDP will work in a pinch.
Yeah, I can definitely see that.
And there's other exploits out there that we've used where you could craft a UDP packet, say against a Unix box. There's vulnerabilities that are UDP based. There's services that are UDP based, and if you could find a vulnerability associated with that UDP service, it may be that you could spike a packet down the wire using UDP, have a exploit embedded in it, enable some new capabilities via UDP. So that was what my goal was to get people to think about UDP and not everything's not TCP.
Right. So if someone does pop your core router and you're unable to detect it for some reason, is there anything worse than that? I mean, is it pretty much game over at that point?
My role in security, for me, it's over with, because at that point, if I can capture your core router and you do not notice it, if I can influence your monitoring and notification, say before I go and pop the router, say I get into your network management system and I can blind you to the attack, or if you even have the capability, instrumentation to notice it at all, if you can get a hold of that core, infrastructure, you can influence everything, any password, any credentials going across that network, you're going to be able to influence. If they're not using strong encryption across that network, like AES, IPsec AES encryption, you're going to be able to influence things. You're going to be able to capture some creds and spread influence across that network. It's just going to happen.
Well, like you said during your talk, when we did our TCP dump of video or podcast last week, and then we've got one coming up on SNMP because we wanted to have you on after the SNMP one. We talked about the ways to capture traffic, and one of the ways you've got the port mirroring, you've got the tap, you've got the hub, and
right.
I didn't even know about ER-span or
it's pretty cool.
Yeah, I mean, not only can you send it to another host on the network, but you could send it to China in this case if somebody was able to get into your box and route that traffic to you. Is that something that you need elevated privileges to be able to do, or how difficult is that to make sure that that is not seen if you were a red team person? And how would you stop something like that from happening on the blue team? Would you just have to notice changes to your config on a regular basis that, somebody just put a span in, that ER span that we didn't know about?
Well, from a detection standpoint, from the edge of the network, from your perimeter edge inward, I would have NetFlow.
Mm-hmm.
I would want NetFlow to get that baseline statistics of who is talking to who, when, where, and how much.
Okay.
That is the key way to find out that something's happening in the network, is to know what's normal, have that baseline. And And if you started seeing traffic from your router's IP address, traffic sourced from your router, and you start seeing a spike out your net flow, if you have that telemetry on the network, that should be a big red flag that you have a network device that's trying to push traffic out, and it's going to be a big spike because normally a router would not be sourcing traffic out your out your perimeter, out your firewall, et cetera. So, and at the same time, from a blue team standpoint, you should have trust relationships locked down. Your network infrastructure shouldn't be able to talk out, have northbound traffic connections sourced from them. You would not want your routers and switches to be sourcing traffic, headed out. And what you can see from a red team standpoint is when you get into these network devices, they do not have those trust relationships locked down at the perimeter edge to lock down the need for access. You don't see filters explicitly blocking at the firewall outbound that the network infrastructure devices and other servers, et cetera, cannot go and send traffic outbound. Why would a lot of your servers on the inside of the network need to source traffic either? If they're not blocking the servers, they're not blocking the network infrastructure as well. So, but if I was a blue team guy and I wanted to stop it, I would start locking down those trust relationships. As far as you're going to have enable access, which is the equivalent of root or admin access to the router to be able to make that modification to the config so that you could turn on ER span.
Okay.
And depending on how busy the VLAN is, the interfaces, you could see a significant spike of traffic. My thing is, I just wanted to show that it was possible because nobody else had shown him. Because who knows what the bad guys might do? I just wanted to provoke thought and get people to think about what could be possible. Because I work on a lot of red team engagements, and everybody's popping shells. Metasploits popping shells all over the place, and we may be finding router configs and end up getting into access into the routers. And in many times, the red teams are extremely talented, but they don't know what to do with the network infrastructure once they get access. It's like, okay, let's go look at the software, grab the config, but the creativity stops there. All the creativity and pivoting is happening on the Unix boxes and the Windows boxes, popping the web apps. And so what I wanted to do is provoke some thought with the red teams. Hey, you got to hold that router. You can do more than just do a show ver, a show run.
Yeah.
And maybe, do a control print screen and snag it to show that you popped the router. If you get that router, there's some cool things you might be able to do with it.
So you work with a lot of red team people. Do you think that they don't access the network infrastructure because there may be too much scope in a pen test, or maybe the network infrastructure is out of scope for many pen tests, so they don't ask if you want to have those checked?
No, they'll end up getting access. In many cases, the red teams will hack the routers and switches. They may end up getting access because they've gotten root access and admin access, and have spreading influence across the network. It's just when you get to the network infrastructure, creativity is limited because there's not a real focus on a lot of the teams. All the focus these days is on malware and web application hacking, and maybe using Metasploit to pop a shell on some Windows boxes that are not patched,
sure,
et cetera. And so there's not a great deal of conversation about using the network infrastructure as a pivot point. So I just wanted to throw that out there. I mean, there's some really good information published. If you go look at the papers that ERNW has over in Germany that they published, the guys who run Troopers, they published some really good papers around this, and FX has been publishing stuff for years. So I just wanted to throw something out there and get some guys thinking myself. Here's some tactics to use. Next time you get a shell on a router, here's a few things you might try to do.
Yep.
Yeah, definitely got me thinking. I heard some things in your talk that you said, hey, next time I pop a router or in my next engagement, I'm going to try this. Are these things that you just came up with and haven't had the opportunity to try yet, or are they proven like exfiltration techniques?
Yeah, a lot of them, a lot of the ideas in that talk I came up with. I was working on the genesis from was I was working a red team engagement, and we had got into a whole lot of network infrastructure, and I was in a time crunch and didn't have all my thoughts together at the time. to go in and show the rest of the team, here's what we could do. And so that turned into a catalyst for me to develop this presentation so that I could go and give it to people. It's like, hey, we get into this infrastructure. Here's some ideas, some things that we could do and pivot, to enable to pivot and gain further influence across the network. And so I just sat down and brainstormed for a few days, what is possible? What is it that us network engineers are taking for granted and understand how they work, but could be twisted, could be used in a twisted way to further gain access across the network. So that's the reason I came up with bending and twisting networks. It's like, because like some of those techniques are understood, they're documented. It's just they haven't been published and talked about from a red team standpoint, like doing the route maps to the policy routing to enable a layer 3 man-in-the-middle attack.
So you do you do some network penetration? So you must have specific tools. I know we've mentioned SNMP blow. In your talk, you mentioned well, that was more for training NRL core. Do you find yourself using things like traffic generators to kind of hide yourself when you're going through a router to kind of build
No.
junk data or anything like that?
No, I'm tools. I like SolarWinds a lot. The NetSNMP tools for Windows. I'll use those. Packet analyzers so that you can see all the protocols out on the wire. Because a lot of times you go and plug into most of these networks. They don't have any concept of port security enabled, and they're bleeding routing protocol information out on the wire. So you can plug in with a packet analyzer and you see like a great deal of low-hanging fruit. You see the spanning tree protocols. You see the IGP, the interior gateway routing protocols like OSPF and the Edge RP, maybe RIP version 2 being multicast out on the wire. And so to go and influence the network infrastructure, it's pretty easy. Just pulling up a packet analyzer. Now to get direct access to the router infrastructure itself, now what it typically takes is a few more steps. You got to go and find the file server, the share that has the archived configs. So one of the guys on the team will end up either finding a directory traversal or get a shell where you end up finding where the configs are archived, so that you can pivot off of it and find the box that's running SolarWinds, the box that's running Cisco Works, or like I said, HP OpenView, so that you can end up going and gaining access to that and pivot off of that trust relationship it's going to have with the network infrastructure to go after that infrastructure directly, because it may be locked down tight. And if if the management plane of that network infrastructure has been locked down tight, then the only way to go get it is going to be to get that network management system. But you may be able to influence the network infrastructure by way of the protocols. And that's real simple to do. You pull up a Wireshark, TCP dump, network miner, et cetera, and you start seeing all those protocols bleeding out there, and you can start coming up with a strategy to influence the network. So it all depends on what you run into, the scenario, and what they make available to you. But if you have a good team, if you have guys on the team that know Windows and Unix and web app hacking, and you've got a network infrastructure type of guy, you'll end up with access. If everybody plays off of each other and strategizes, you'll end up pivoting to you end up having access to the network. So it's just unless there's a network engineer on the team, it's not the target. Everybody's popping Windows and popping Unix, popping web apps, because that's what they know to do, and that's fun.
Sure. Yeah.
Except for the network guy.
The lonely network guy.
So like 100% of the time, you're going to be owning the network if you have a good team like that?
Yeah, well, you end up taking the network over. But our experience is if we build a good team, if we can put together a team, if you got
well-rounded. Yeah.
Well-rounded. If you got the different SMEs with the different skills, you're going to end up taking everything over, because they can play off each other's strengths, expertise, and you can take over these networks. So
you're owning networks with TCP dump and then Wireshark, basically. That's it.
Yeah, but you can plug into these networks if they do not implement port security. if they're not implementing, some really strict controls at the access layer, they're going to make some mistakes out there. You're going to see those protocols there, and then you could go and pop up something like, you could go download that VM. I shared it in that presentation, that the Navy core tool,
Mhm.
or fire up a Quagga router on your Linux distro, or go download Huawei's ENSP, or fire up Dynamips.
Yep. Yep.
And join the network and start influencing things, start acting like a router, and start influencing traffic. It's there. It's totally easy to do if they have not, or if they're not OPSEC aware in the network infrastructure, and they're advertising those routes out. You'll just join it.
So now, when I was a little shaver, little dude in IT, we had a router, and we were told to put ACLs on it, and that was foreign to us at the time. And one of the other controls in this case was, and this was in the Navy, so that's how bad it is. So one of the things they mentioned was putting in port security. Now, from what I gathered, port security is only somewhat effective. Isn't that similar to like MAC filtering on a wireless router, where if somebody could just figure out which router or which MACs you were allowing, then they could get around port security? How is his port security going to help? Is it a low hanging fruit kind of thing, or is that an actual viable protection for your network?
The port security, say if you're doing DHCP, you could turn on one. You could go and turn on. You could enable the lock down the trust relationships for DHCP, so that you wouldn't allow the devices plugging into the network to try to spoof a DHCP server. You'd lock that down, and then you could go in, and I would not do the MAC address filtering. But you could go and lock down the number of MAC addresses you want to permit to come from that interface, and implement authentication at the access layer. One of the things I'm a big fan of to stop the proverbial APT is to use two-factor authentication. I'm a big fan of when the users log in and get access to the network. If you really want to go and use port security to the strongest level, use two-factor authentication. So when the user comes onto the network, you're not using a static password to do 802.1x, that you're going to use two-factor to join the network. And also down at that layer, I would lock down the trust relationship using VLAN access list, because what I look at is the OSI model. Being a network guy, everybody wants to forget the OSI model after their Network Plus or CCNA course. They suffer through the OSI model, and then they forget about it. But I look at that layer 2 security. If I was going to lock things down as a blue teamer, I would use VLAN access list to lock down those trust relationships in that VLAN, and only permit the host out there in those access VLANs to communicate to the north, to what they absolutely have to, and use private VLANs, so that the host can only talk to, say, the interface that's headed northbound toward the routers. So there's multiple tools you can use to lock down those connections. And at the same time, with your routers, you could turn off the routing protocols that are dumping multicast out into a stub VLAN, so that someone, if they're able to go and plug in and pull up Wireshark, if they got access to the network, if you don't advertise those protocols and multicast them out there in that VLAN, they would never see them, so that they could try to influence them. So there's lots of mitigations. There's not just one mitigation at the access port level. You got to think it through. And what you will see happen is one or two things may be fixed, but they typically miss one. You may not see spanning tree, so that you could go and use something like Yersinia to try to influence the spanning tree protocol. But even though they've done that, they may be dumping the routing protocol out in the VLAN. So the routing protocol is a vector, at layer for you. So it's different. Like from a red team standpoint, you just got one of the protocols they're going to let you influence.
Yeah.
So when a company wants or needs a private circuit, usually they'll get an MPLS circuit from one of those vendors, right?
Right.
You can trust the vendor that circuit is truly private, right?
Yeah, sure. Yeah, the whole thing with MPLS, I've built a great deal of MPLS networks over my career, and I'm a huge fan of MPLS. But you've got to know where the marketing begins and ends when you're dealing with technologies, as you guys well know. And VPN, that whole term, virtual private network, does not imply encryption. If you want encryption, you've got to go in and add encryption to your connection. And there's a big misunderstanding with many people who buy MPLS circuits that they assume that they're getting an encrypted tunnel across the carrier's backbone, and that is not indeed the case. And so what I've been discussing with many people is, from the standpoint of MPLS, is that MPLS runs across a carrier core router infrastructure that is probably also carrying internet traffic across that same routed infrastructure, which is BGP traffic. And it's well known, if you're following many good security feeds off of Twitter and blogs, that BGP is being hijacked. It's been hijacked for years.
Mm-hmm.
Well, what a lot of people don't know is whoever has access to those BGP routers in the majority of these telco networks has access to your MPLS private VPNs as well. And so if whoever it is that's doing this, like the certain scenario of the gentleman up in Canada, the telco in Canada, that was hijacking all the service provider networks for the purpose of capturing Bitcoin. If they're going to capture that, why would they not go and capture go and try to influence the MPLS VPNs for, say, a bank?
Sure.
If they got trying, or healthcare, or some other organization trying to get private information.
So you're saying that the term VPN, that's not necessarily encrypted traffic by definition?
No, VPN could be your VLAN. A VPN could be an X.25 PVC circuit, a frame relay PVC, an ATM PVC, a GRE tunnel. If you've dealt with the old legacy routing protocols, or network protocols like the AppleTalk, IPX, DECnet, we used to send all those protocols across a GRE tunnel. Well, that could be defined as a VPN, and it's not encrypted. Now, granted, you could go and add similar to the MPLS. If you wanted encryption, you could encrypt the GRE tunnel if you wanted privacy across the internet backbone. Same concept with MPLS. If you want true privacy, if you want confidentiality and integrity ensured, you have to go and overlay IPsec encryption around that. And say, like, if you're in a Cisco network, and you could use something like Cisco Get VPN to encrypt that MPLS traffic. But what I want to make people think about there is, if you start asking questions from the telco about that, what if, and the telco offers you a encrypted VPN service, you're still inheriting a trust relationship with the upstream telco. Now, it's great that you're going to use the MPLS circuits, and I would too, because it's economically feasible, and it's a great service for running your voice, video, data center type services across Metro E, et cetera.
Uh-huh.
But the confidentiality and integrity, you need to own, because if the telco gets hacked, or the telco has an engineer that goes rogue and starts hijacking traffic and wanting to influence traffic, well, why if they're configuring your encryption, what makes you think they couldn't go and influence your network, your crypto, your encryption, as well as hijack your routes? So I'm just really paranoid about trust relationships, where that trust relationship begins and ends, and who's controlling and who's monitoring it, and who's going to be accountable for it.
So let me ask a question about the encryption part. Where does the encryption in an MPLS circuit start? Is that at the telco to the endpoint, or is that supposed to be from point A to point B, with your telco kind of being like the original cloud before it actually became called a cloud? Or is there different ways of doing the encryption so that your connection is actually more secure?
If I was an enterprise buying the MPLS circuit, I would want to put my own VPN encryption capability on both ends of the circuit, and just use the MPLS as transport.
Mm-hmm. Okay.
And the MPLS is a great transport service. I'm a big fan of using it for a transport service, but I would want to control my own encryption to guarantee that my team was monitoring and ensuring the confidentiality and integrity of my traffic, especially if I was under compliance for like HIPAA PCI, SOX,
Yeah.
NIST, NERC, FERC, whatever compliance you're under.
Yeah.
If I'm the CISO, I'd want my guys to be controlling the encryption because if I'm accountable for it, I want to control it.
Yeah. Yeah. When I was in the Navy, we had dedicated circuits, and point A and point B would call each other, and then we had this hardware encryption device where we had to run these paper tapes through at the same time to synchronize the crypto and everything to make sure all the data works. It's much simpler in the enterprise now than it used to be, but yeah, that was the earliest forms of crypto I remember having. Do you have any stories of how did the crypto used to be that hard to do for the enterprise? I haven't actually done any real networking like that in the civilian world. So, do you do hardware encryption, or do you just rely on something like OpenVPN to do your encryption for you?
Well, my personal experience, I'm in full disclosure, I'm a big Cisco fan. So
No.
if you're a hammer, then the world's a nail. So I'm so I go and solve problems with the Cisco firewalls and routers for the VPN. But there's lots of ways, whatever your Kool-Aid is, whatever your preferred method of doing a VPN. But I would just want to control that if I'm accountable for it, to be able to know that the confidentiality and integrity is ensured, and use the telco for transport, because they do that really, really well.
Yeah.
And it's a great service. But people are people, and people can be influenced and compromised.
Cool.
And think about this with the endpoint encryption. If you outsource that to the telcos, what if you're dropping circuits out around the world and the telco doesn't have the service at the other end?
Yeah.
I mean, you're trusting people in different parts of the world that may not be friendly next week to us. They may be kind of sort of friendly last week, but next week may not be there, and you've got circuits popping out there, and they control your encryption.
Yep.
If you're good with that trust relationship, more power to you.
Well, it's similar to cloud data. They say, oh yeah, you put your data up into our cloud and it'll all be secure and we encrypt it for you. But they may encrypt it, but they also have the ability to decrypt it. So, you're better off encrypting it before you send it through, up into the cloud, so that, they'll encrypt it again. But if somebody cracks their keys or they gain access to that, you want to be able to know that your data is still semi-safe. Even though it may be in the hands of bad guys, they're going to take forever for them to be able to crack that. So, yeah, having full end-to-end encryption is going to be better than hoping that your provider's actually doing a good job for you. So, yeah. And especially since you mentioned in your talk about lawful intercept that if you're not encrypting your data and they go to the telco and they can take your traffic and it's not encrypted because you're expecting the telco to encrypt it, then they're going to get your data anyway. Right.
There's lots of different attack vectors to exfil your traffic. It may be out of your network, or it may be the upstream provider.
Yep.
I mean, look at the BGP hijacking that's happening.
Oh yeah.
I mean, there's no telling who all's traffic right now, because they're not looking at monitoring their IP prefixes. How do you know somebody's not hijacking your IP prefixes and sniffing your traffic right now? And if they're doing it with the BGP, you've got to think that they're doing it with the MPLS. Why not?
Yeah.
And, which I've heard from one individual that has actually happened to them, that they've caught that happening where their MPLS network was compromised. It's just not being widely talked about right now.
So even if you do outsource your encryption to your vendor, this idea of lawful intercept still falls into play, right? They could decrypt it on the fly, do the lawful intercept, and then re-encrypt it. Is that plausible?
With the lawful intercept, that's going to happen typically going to be out of the telco cloud. And if it happens in the telco cloud, if across the core backbone the traffic is encrypted, all they're going to get is and if they were to break into that lawful intercept capability, they're just going to get a copy of your encrypted traffic. So they're going to have, if they wanted your traffic before it got encrypted, they might break into the enterprise And if you did not have a feature set that included the lawful intercept, what they might do is have to load some code on your router, give with the lawful intercept feature set, and enable that capability so that they could do the lawful intercept attack vector and exfil your traffic before it gets encrypted. That might be an attack vector. It all depends on where in the kill chain, where in that chain of trust that they get access. It's all about it's all about that chain of trust there, because if it's encrypted, it's encrypted. So they're going to have to get it before it gets encrypted. So it's going to be where is the encryption happening? Is it happening in at the telco edge, or is it happening at the customer prem? Because if they do that, they're just going to, if they do it in the telco cloud and you're using encryption, all they're going to get is encrypted data.
Mm-hmm. Right, but what if the telco was the one doing the encryption? Could they still do the lawful intercept? I mean, I guess theoretically they could, right?
Right. Well, they could possibly do it off of your CPE. Your CPE might be able to upload the code to your CPE. If you have enough memory, they could upload the code to your CPE and then enable that capability at the CPE, the customer prem device that would be doing the encryption. They could possibly go and configure it there and execute the lawful intercept. At the same time, they might be to do the ER span or any number of other methods to exfil traffic. It's just limited by their creativity and imagination, what features they want to utilize for that purpose. I mean, they could go old school on you and maybe set up a GRE tunnel backdoor and pump traffic out over that. Who knows? You're only limited by the imagination of the guy who's gotten access.